Hello everyone, thanks for joining us today. My name's Andy Schumacher. I'm the head of the plastic packaging group at Schaefer. I've been in the industry for about 20 years and have worked for a variety of different manufacturing companies of different styles of returnable packaging. It's a really awesome industry to be a part of. I feel like we get to affect people's top and bottom lines, but we also get to affect the environment and other socially responsible aspects of people's mission statements. So really an exciting industry. Here with me today is Brandon Hoots and Mark Ward. I'll let them introduce themselves.
I'm Brandon Hoots. I've been in the industry about 13 years, specialize more on the containerization and custom injection molding. And my background is the packaging containerization part of molded plastics.
So I'm Mark Ward. I've been doing returnable packaging since about 1994. Started mostly in vacuum thermoform products, custom design trays, shipping containers, and returnable packaging, custom what we call dunnage, custom protective packaging for the last 20 years with Schaefer.
So the purpose of our presentation today is really talk about what trends are affecting our industry right now and how they might impact end users, supply chains, etc. We'll get into that in a little bit, but before we get into that, we just wanted to kind of define what returnable packaging is and kind of lay out the groundwork of what we're going to talk about today. So the first thing is the company we work for makes plastic returnable packaging, but the important thing to know is that returnable packaging really comes in a lot of different shapes and forms. Steel racks, even wood crates sometimes are reused over and over again. Obviously, liquid bulk containers is another form of returnable packaging. You can see things all the way down to dairy crates and shells for beverage companies. So there's a lot of different shapes and forms, and for the most part, we're trying to talk in very general terms about returnable packaging and not getting into the details of a specific industry. Here's a list of a bunch of different industries that in North America today use returnable packaging. I think most people are probably familiar with the majority of those industries, and obviously there's still room for growth with returnables in some of these industries, but the majority of them have already begun the conversion or are fully converted to returnable packaging. So this is just a list of different criteria or opportunities for why returnables may or may not make sense. I feel like there's a few items on this list that are very, very important. Things like the more expensive your expendable packaging is, obviously the easier it is to justify the returnable packaging methodology. High volumes obviously help support any sort of supply chain loops, etc. The big one that we're seeing lately and a major trend is just the overall welfare or care for people's employees and how they interact with different packaging solutions. And so we're having a lot of conversations about ergonomics and safety and things of that nature. And a lot of times returnables can help with that arena in a big way. And then probably the other big one is the underutilization of cubization within trailers or space within transportation modes is obviously a way that returnables can really help. But this is the bulk or majority of our conversation today, or presentation, if you will. The first three, the social environmental, we're going to talk about the technology and asset management. We're going to talk a little bit about that trend. And the main conversation is the total cost of returnable packaging. The bottom two items we have on the list, labor costs and labor shortages, was originally going to be part of a presentation that was slotted for the 1:30 time slot, but one of my colleagues was not willing to risk coming to Atlanta this week, so but I did want to point that out. It's obviously a major trend going on right now. Most companies and most industries have labor cost issues, labor shortages, and returnables has an impact on that, sometimes negatively and sometimes positively. And then the other one is the impact of automation as it relates to returnables. Returnables have a very, very high usage rate within automation, automated facilities, and the continual growth in that arena has really made it so that you have to think through returnables through the entire supply chain, including the automation component. So that presentation will probably be at the next trade show we have, and it'll be really, really good. So come back. Brandon, this is you.
So when looking at a returnable packaging solution, a lot of industry now is more towards trending the social environmental aspects, obviously global warming, stuff like that. So when looking at returnable packaging in a high level, there's a negative segment in the world of plastic being bad for the environment, right? But I think there's a misconception of plastic being bad and what that means. The industry of industrial packaging, returnable packaging, there's actually a good use to what you think of plastics in the sea or litter in the environment. Post-consumer product is kind of what companies look for to reuse and recycle. We can use a plastic bottle, it's called post-consumer product, and then cycle it back into a plastic container, which is used industrial. It lessens the carbon footprint in the environment, which it seems to be the trend in most larger companies or companies in general. You want to clean up the environment. Obviously, returnable packaging reduces the footprint of waste. Obviously, we're always trying to benefit the environment and lessen our footprint on the landfill portion. The greenhouse gas, I just touched on the carbon footprint, reutilizing the post-consumer product that you see a lot in anything from a Clorox bleach container to a returnable bottle, water bottle that we can put back into a plastic bin type of application.
Yeah, I would just add there's a lot of industries out there trying to attack the whole plastics industry as a whole right now, and we're, as an industry across the board, really having to fight a battle that we don't even think makes sense to us, because what we do and what Brandon's talking to and referring to is everything's reused. So it's not about consumer waste. I've never seen one of our totes, floating through the ocean in these piles of plastic. I mean, it's against everything we stand for. So, but that is a trend that we're seeing. It's something we're combating against a lot of the expendable companies and the lobbyists in their industries. So it's something that's real, and it's something that we're having to fight against on a day-to-day basis. The RPA is actually very much actively working together as an entire entity to try to combat that conversation. Sorry, Brian, go ahead.
No, that's fine. So how granular can cost savings go? So looking at a returnable loop, there's obviously a lot of upfront costs, but ROI usually pays for itself within a year, in most cases. You have a one-time ship pack, expendable pack, that more or less would take your end product, and get it to the end user. Returnable packaging is substantially the complete opposite. You would have multiple loops. You'd have the upfront cost of that loop, but essentially it's to last for many, many years. Again, eliminating that carbon footprint on waste, and then also the waste that's in our landfills. There's different ways to look at cost savings. Obviously, there's three types of potential transit items. You have rail, car, and truck, and also sea containers, so I guess a fourth. There's different processes of returnable packaging, from straight wall, larger bin applications to collapsible applications that would have a better NAST return ratio. So you'd have your upfront cost of a one-way transit, but then your return fleet, you could get more containers back, eliminating that carbon footprint and then fuel consumption. And then the customization side,
So that really comes down to like the final mile, if you will, within some of the applications. In some markets, a lot of what the different modes of transportation are really defined, and so when you started looking at returnable packaging 30, 40 years ago, you had to go through and make sure you figured out what type of vehicles, what type of trucks were being used, et cetera, et cetera. But over the years, basically within returnables and in most industries, the footprints have been really designated or predefined. So the decision-making process doesn't really start at the higher levels anymore. You really get down into the detail or the granular component of it and the customization side of it. So what I mean by that is, like, the food industry is all 40-48. The automotive industry and general manufacturing industry in our country is all 48-45. Beverage is 37-37. Other beverage supply chain 44-56, et cetera, et cetera. So a lot of those decisions are made for you because of the standardization we have in our country. Ironically, in other parts of the world, right now, they're still having to try to define those standards. So you go to China and you have a lot of different countries trying to prevail or show dominance with their transportation modes. And so China deals with the issues or concerns with different modes of transportation within their country. They have European standards, they have American standards, and they have Southeast Asian standards. So there's lots of struggles that they go through at the higher level in their decision-making process. In our country, it's really much further along. Those kind of definitions are defined, and we get kind of more into the granular detail of what it is you're packing. So meaning the detail of changing the primary packaging so that it fits the returnable better, or so that you can get better weight density or better part density in the container.
So on that previous slide, there was RFID asset management. Obviously, with returnable packaging, there's upfront costs, more so than expendable pack. So what companies in this industry tend to or are moving towards is RFID asset management. Essentially what that is tagging each type of container and putting it up in the cloud, and then more or less knowing where your container is at all time, from customer to end user, and then at real time knowing where in loop or transit that container is real time. Knowing that, it substantially brings the cost down, because more or less you can track damage, lost containers. And that's a high level of that.
Yeah, right now there's a major trend within the automotive industry right now, and they are working with a third-party company called Surgere, and Surgere is really went out and got the automotive companies to work together, which is a small miracle, and they're all working with the same premise in mind, which is, let's figure out how we can track and trace these containers as an industry, not individually. And really, that's probably the biggest challenge that the United States has as a whole with returnables. When you go to Europe, all the companies over there are working together to maintain their assets. And in our country, it's very polar opposite. And majority of companies think that they're lone rangers and can do it themselves. And so it's been a really pleasant surprise to see what Surgere has been able to pull off the last couple years. They've went out and they've really got people working together, and they're getting, real information instead of, having companies out on an island trying to figure things out on their own. I think the market really needs that exact process to be done in a lot of different industries right now, would be my opinion. But it's a pleasant surprise that at least one industry is doing it right now as we speak. I think every single major OEM is working with Surgere, with the exception of one. So, anything else, Brandon?
No.
Okay. So as I mentioned before, regarding the supply chain distribution networks in the U.S., a lot of them are already predefined. So, and what that means is what I talked about with the footprint earlier. The one thing I forgot to mention is it really comes back down to trucks and trailers, and we don't have a lot of sea containers moving across our country unless they're coming from outside of our borders. But for the most part, people use 53-foot trailers, and that really helps define things. Ironically, the food industry uses 40-48 footprint, which makes absolutely zero sense whatsoever from a logistics standpoint, but it was defined back in the early 80s, and it's always stuck. So I have seen a trend for a lot of food companies to start looking downstream further and to start trialing and trying to do things different with different footprints further downstream within their supply chain. I think it's a challenge because they have so much standardization within their automation and other things, just things like flow lines and other aspects of their business. But it is something that people are realizing is a real cost to their bottom line, and they're trying to figure out solutions around it. Anything else on that, Mark?
I mean, it's like you said, because of the mode of transportation, you pretty much already have predetermined footprints that you can work within. Everything we're doing with returnable packaging as an industry is maximizing what we call QPC, quantity per container. How can we get the most product with the least amount of dead space onto the container? So to your point, the 48-45 footprint, the 48-40 footprint are pretty standardized in most industries. We're looking to take that to the next level and say, okay, how can we get as much of your product, whatever that is, protect it the best way possible, and get the most efficiency out of your transportation. Fuel costs are constantly climbing, destination points are getting further. So it's always that, where can we have that positive impact on returnable packaging, but now it's pushed so much into the logistics side, transportation costs, fuel costs, things along those lines. It's really all melded together, as a whole systems approach to what we do.
Yeah, I think the next part of our presentation is really talking about the trend of really the granular, looking specifically at that final mile. Final miles is really referred to in the retail industry a lot. It's not referred to in a lot of other industry, but I think that verbiage applies to almost every industry. It's trying to figure out how do we get that additional savings? How do we make sure we're protecting our employees? How do we make sure we're protecting the environment? How do we make sure that we don't have any safety concerns out there? So before I get into that, I mean, we're in constant conversations with companies right now about cold chain and trying to figure out how to preserve different cold chain aspects. We didn't get into that specific example today, but that's one example of really kind of that final mile, if you will. And Mark's going to get into a bunch of kind of more general manufacturing solutions and how to save money as it relates to some of that detail.
So customization is really a key aspect of our industry. So we have standardized products, pallets, containers, standard footprints, but how do we take a standard product and really make that fit the individual customer's application, whether that's their product, whether it's part protection, maximizing the amount of parts that go in. So we look at that from a number of different ways. One is the part itself. What are the special characteristics of that part? How does it have to be protected? In the automotive industry, you may have a piece of interior trim. So it has to make it from the manufacturer to the assembly line in a package that can't put any mar or abrasion or any kind of defect to it. So we're looking at specific types of materials, always testing new materials that we can use for these applications to make sure that a high gloss painted surface needs a different form of protection than like a headlight lens. And you may have molded in wood grains into materials. Each of these have their own requirements. So we're always looking at what is that specific part, what is the surface protection we need to do. Are there certain areas on the part that can't be touched? Sometimes you have electronic parts and there's certain open phases and open components within there we can't let dust or contamination get into. Part orientation. A lot of times our customers want to take the part out of the package in the same orientation in which they're going to install it line side into the finished product. And then size of containers and trying to maximize again that QPC. How do we get the most of any single product into a single container? So some of the examples we've got just show you some different approaches that we do. And these are just some engineering drawings. They're very basic things, but on the first side, we first looked at this project and we designed it using foam and plastic corrugated. It was a simple trim piece. and we looked at, it had a kind of an odd arc to it, so we needed to support it properly, and we were able to get 6 parts per container. Well, by going to a different material foot approach and removing the foam, removing the plastic corrugated, we actually took fabric and sewed pouches, and we were able to get another part in there. So even though it's only 1 part and it's not a huge jump, it's still 1 more part. So somewhere during the line of that total package, cycle and volume you need, you're starting to now reduce the number of total packages you need in your system. So here's another example where, again, we had a foam set, and you see a picture of the part, and we were initially able to get 3 parts in there. Again, we can't touch the inside wall of the containers. We want to protect that part so it could be dropped, it could be bumped, it could be put on a forklift and driven through a plant and be vibrating, and there's no damage to the part. So we always got to kind of create this air cell, soft protective mode around every part. But when you do that, you're restricted sometimes. You start limiting the number of parts. Again, we change to a fabric application. We go to much thinner material. We don't have as much bulk of material, so we're able to go from 3 to 5 parts, increasing that QPC again. So here's another one that's, again, kind of an interesting approach. The first is, we call it our NF container. It's one of our standard footprint containers, right? Standard handheld container. And what we found is that no matter how we put the part in the container, it was very close to the wall of the container. We felt unsure that if it was handled roughly in an environment, that part was going to probably be touching that inside wall and potentially damage the part. So we looked at another one of our container families that had a slightly larger internal dimension, and we found out, okay, this works well. We have a little bit more of an air cell. The part's not going to touch the wall. But again, how do we keep pushing the envelope? How do we get more parts in there? So we went to another orientation, and we just basically took the same container, same part, changed the orientation, and now, we go jump up to 5. So we're getting 2 more parts per container. Again, the final goal, reducing the total number of packages you need in your system, reducing your overall investment cost.
Oh, sorry.
And this is, where we kind of really start to make some leaps and bounds. That was a simple plastic corrugated material, just like paper corrugated, except it's plastic. It's got a little longer life endurance, side to it. Most of our packages are designed to last for the life of an automotive program. So that's a 4-year program. So everything we're doing is built for endurance. But again, we had a small part. It's a little emblem plate. We were able to get 80 per container. It's a pretty, good volume. But we took foam, we used a water jet machine, orientated the foam or the part slightly different, and we're able to put the part in, and again, we jumped to 96. Same container, but we go from 80 to 96. And this is sort of our last example, and this is where we really start to see some changes. On the left side, again, plastic corrugated, very simple, straightforward set. We had a handheld tote, and what we did was we had 3 different layers of dunnage, 3 different trays, and we were able to get, I think it was 7 in each layer. So you have 3 separate loose trays that are in the container that have to be taken out and removed to go to each layer. So you've got a little more handling, which is going to affect your load time, unload time, applications line side. But we changed that, changed the orientation of plastic corrugated, stand the part up on its end, and we go from 21 parts to 63 parts of the exact same part. So again, just drastically reducing the customer investment and the number of packages they need to fulfill the same system cycle.
Yeah, and I think everything Mark's talking about, we really are referring to the dunnage side of the business, but we're having a lot of conversations within the market about people just looking at new custom containers, pallets, etc., of trying to find ways to optimize their supply chain. I mean, all it really is trying to figure out ways to reduce overall costs by, reducing logistics costs and handling. Every container someone handles is not just the cost of shipping the container, it's all the handling in between. And I think most supply chains have shown that the biggest issue or concern long term with the supply chain is usually the material handling component and all the additional touches above and beyond the touch point that really matters. So that's pretty much what our presentation was about today, all the different trends that we're seeing in the marketplace today as it relates to returnables. We did leave a few minutes for a Q&A if anyone has any questions.
Sure.
All right, what's up? That's interesting. You know what's interesting about that question? First of all, great question. Is that in North America, I'd agree with you. There is kind of a lack of innovation in that arena. There are a couple companies that I've seen here today that are more European-based companies that are bringing some solutions, and I think their ideas are really good, but they're also very expensive and very European. So I think there will be a trend moving forward to try to close that gap, if you will. And it's a matter of, most companies are really trying to eliminate or remove forklifts from their operation altogether, anywhere in any way they can. And some of that's the technology conversation I mentioned earlier, and AGVs, things of that nature. Some of it is carts within a cart systems. Some of it is mobile pallets that you can pull containers off the pallet, if you will, but still keep the solution mobile. So there are some cool things coming, but I would agree with you. There's been a major lack of innovation within the U.S. I think a lot of that has to do with the longer supply chain loops, though, because when you go to Europe, obviously the average distance between supplier and OEM is, for any market for that matter, is much shorter distances. So they can get into more expensive solutions because they don't have to buy the loops that we have to buy in our country. So the overall cost is probably pretty comparable because they're buying so much less packaging than we are in our country. That's just, I guess, my opinion on the subject, but it's a good question. And I do see that trend coming, especially some really cool solutions I've seen over in this part of the show this week.
So you're saying that recycled cardboard is starting to get more expensive than the return that you get on it. Do you see this kind of going into warehouses and the way that we ship things to people, or are we just going to throw out cardboard?
Yeah, so it's a great question. It's a complicated answer because, I would have said yes to that question a few years ago, but the .com business is going the opposite direction of where my thought was where we were heading. The .com business really complicates that question a little bit. It used to be, lots of bulk shipments and inventories out there of everything in our country, the way we did business, and we're becoming much more lean. And so with that kind of change in methodology, I feel like there's a lot of uncertainty, and people are not going to invest in large returnable loops into the consumer side of things, if you will, until that kind of gets really defined. And longer term, that's just my opinion, but I think I struggle with it right now just because there's so much unknown with how far .com will really go, and I think it will change everything. But I did start seeing one retailer was examining it very, very closely and trying to find ways to use returnables with their largest consumables, if you will. They even went as far as doing trials, but no one ever pulled the trigger on real life application. So it started to make some headway. I have seen it in Europe, but not even to a larger scale. And it's mostly been in the produce industry, to be honest with you. Obviously, DSD is doing that today. That's what DSD is, right? That's beverage is the primary user, but bakery and some of the dairy applications as well are all really going the final mile. But and they're going upstream all the way. But in some of the other industries, I don't see it yet. Specifically, like the consumer goods industry. Yeah. Sorry.
No, you're okay.
Yeah.
On your plastic corrugated, does that fold on the bottom of that container that you had? set down in there?
Yeah, so sometimes it's a foam base pad that's absorbing shock for the handling of the product. Sometimes it's an incorporation of maybe a foam bar that's glued to a plastic corrugated base pad. Sometimes it's a cell divider that has a foam component to cradle the part with inside. So we blend a lot of materials. That's a fairly common.
So if I wanted to get the plastic corrugated, if I just pull that out and put it flat.
It can, yeah. We can design it like you would find in a case of wine or something where you could take it out and go flat.
Accordion.
There's also some things where you can have collapsible dunnage, which we call that returnable packaging, especially in the fabric base, also in a collapsible container. So the nice part about that is you're not removing the dunnage. There's no chance of it getting lost or damaged. It's still in the container, but yet you have that collapsibility factor. So when you return shipments, you're able to get a lot more back on your truck instead of just a lot of dead air.
Yeah, the felt might still be a little rough for us. The plastic is a bit better to go with some more finish.
Sure. And most of our materials have a lot of different lamination variations. So whether it's what they call spun bond, which is a non-woven, there's several non-woven materials, some foams, and then different textile fabrics.
Any other questions? Well, thank you for coming, all 10 of you. I appreciate it. Thank you.
Thanks.